This is a Cambridge IGCSE paper 4 extended talk through from June 22. A list of substances is shown. Answer the questions using the list of substances. Each substance may be used once, more than once, or not at all. State which of these substances is a reactant in photosynthesis. So remember, you react carbon dioxide with water to form glucose plus oxygen. So we're looking for either carbon dioxide or water. There it is, carbon dioxide. What is the main constituent of bauxite? That's aluminium ore, which contains aluminium oxide. Our two products of fermentation. Fermentation is when yeast anaerobically respire glucose to produce ethanol and carbon dioxide. So let's double check that both those products are there. We have ethanol, we have carbon dioxide. Is used as a fuel. We need either an alcohol or an alkane. There's the alcohol again, it's ethanol. Remember, when ethanol undergoes complete combustion, it produces carbon dioxide and water. Is a gas used to convert iron into steel. That's quite niche, but that's going to be oxygen. Is a greenhouse gas. Gosh, carbon dioxide is coming up an awful lot. Remember, carbon dioxide, methane, water vapour, nitrous oxides. They're all examples of greenhouse gases. Is a gas that is approximately 78% of clean, dry air. That is nitrogen. Is a form of carbon, so you're looking for something like diamond or graphite here. So let's see what we have in the list. Whoop, diamond. Atoms are made of protons, neutrons, and electrons. Atoms of the same element are known as isotopes. Complete the table. Electron has a relative charge of -1. A neutron is neutral, so it would be 0. What about the mass? Well, a neutron and proton both have a mass of 1. 24 magnesium and 25 magnesium are isotopes of magnesium. Complete the table to show the number of electrons, neutrons, and protons in these isotopes. So, let's start with the number of protons. Remember, they will have the same number of protons if they're isotopes. The answer here is 12. It's the atomic number. Because they're neutral, it means they have equal numbers of protons and electrons, so I'm happy to put 12. Then the slight difficulty comes from the number of neutrons, which remember is the difference between the mass number and the atomic number, so that's 12 for this isotope and 13 for the one below. Explain why magnesium ions have a charge of 2+. This is because they must have lost 2 electrons in order to get that 2+ charge. So they must therefore have 2 fewer electrons compared to protons. That's the only reason we can have that 2+ charge. It's due to the loss of electrons. Magnesium ions have the electronic structure 2,8. Give the formula of the following particles that have the same electronic structure as magnesium. A cation, which is a positive ion. So we need them to have the electronic configuration 2,8. That gives us 10 electrons altogether. So to have a positive ion, you need an extra proton. So you need an element with 11 protons. So here's 11 protons belonging to sodium. So it must be Na+. A negative ion. So we need it to be 2,8 again with 10 electrons, which means we need 1 fewer proton. So that's 9 protons. Use our periodic table again. We need to look at that atomic number. So it's a fluoride ion, F-. And then is an atom. So it needs to be neutral, so it needs to have 10 protons. It's neon. This question is about sodium and compounds of sodium. Describe the bonding in a metallic element such as sodium. You may include a diagram. So sodium is made up of a regular arrangement of positive metal ions surrounded by a sea of delocalized electrons. Remember, it does metallic bonding. So sodium is made up of the regular arrangement of positive metal ions surrounded by a sea of delocalized electrons. We've run out of space. There is an attraction between the positive metal ions and sea of delocalized electrons. Describe how solid sodium conducts electricity through those electrons that can flow throughout the metallic structure. Some properties of sodium chloride are shown. It has a melting point of 801 degrees Celsius. It's a non-conductor of electricity when solid. It's a conductor when molten. It's soluble in water. Name the type of bonding in sodium chloride, where you have a metal and a non-metal. So that should be screaming ionic bonding. Explain why sodium chloride conducts electricity when molten. Simply because the ions are free to move, unlike in its solid version where they're not free to move, hence why it doesn't conduct. A student determines the concentration of dilute sulfuric acid by titration with aqueous sodium hydroxide. 25 centimeters cubed of 0.2 molar sodium hydroxide is transferred to a conical flask. 3 drops of methyl orange indicator are added. A burette is filled with sulfuric acid. The acid in the burette is added to the conical flask until the indicator changes colour. The volume of acid is recorded. This process is known as titration. The titration is repeated several times. Name the piece of apparatus used to measure exactly 25 centimeters cubed. It's going to be a glass pipette. State the colour change of the methyl orange. So it's going from alkali to acidic because you're starting with that indicator in the sodium hydroxide. You're adding sulfuric acid, so you must remember the colour change from alkaline to acidic. It's going to go from yellow to orange. State how the student decides that a suitable number of results has been obtained. It's all about getting concordant results, so that means at least 2 results are within 0.2 centimeters cubed or less. 20 centimeters cubed of sulfuric acid reacts with 25 centimeters cubed of 0.2 molar sodium hydroxide. The equation for the reaction is shown. Calculate the concentration of sulfuric acid using the following steps. Calculate the number of moles in 25 centimeters cubed with 0.2 moles sodium hydroxide. Use this formula triangle, which states that number of moles is concentration times volume. Our concentration is 0.2 mole. The volume, be careful, it needs to be in decimeters cubed, so divide by 1,000. The answer here is 0.005 mole. Determine the number of moles of sulfuric acid that will react with sodium hydroxide. So you know you have 0.005 mole. What must the number of moles of sulfuric acid be? Check that mole connection, it's 2 to 1. So we take that number for sodium hydroxide and we divide it by 2. Calculate the concentration of sulfuric acid. Use that formula triangle again. It's number of moles divided by volume. We just found the number of moles. The volume we were told was 20 centimeters cubed. So again, get that into decimeters cubed by dividing by 1,000. The answer is 0.125. This question is about compounds of sulfur. Sulfuric acid is manufactured using the contact process. This manufacture involves 4 stages. Molten sulfur burns in air to produce sulfur dioxide. Sulfur dioxide reacts with oxygen to form sulfur trioxide. Sulfur trioxide combines with concentrated sulfuric acid to form oleum. Oleum reacts to form concentrated sulfuric acid. Write a chemical equation for the reaction occurring in stage 1. So we're getting sulfur, we're burning it in air, which tells us there's oxygen to form sulfur dioxide. Dioxide means there's 2 oxygen. Make sure it's balanced. It is. State the essential conditions needed for stage 2. Write an equation for the chemical reaction that occurs. So we need a high temperature of 450 degrees Celsius. We need a pressure of 1 to 2 atmospheres. We need a vanadium 5 oxide catalyst. And now we need that chemical reaction. So we're being told it's sulfur dioxide reacting with oxygen to form sulfur trioxide. It's a reversible reaction. And then make sure it's balanced. You need a 2 here and a 2 here to make sure you have 2 sulfurs on the left and right side and 6 oxygens. Write a chemical equation for the reaction occurring in stage 3. So we have sulfur trioxide combining with concentrated sulfuric acid to form oleum. So copy that formula of oleum carefully. Again, make sure it's balanced. It is. Name the substance that reacts with oleum in stage 4. Unfortunately, you just have to learn this. It's water. Hydrogen sulfide has the formula H2S. Complete the dot and cross diagram to show the electron arrangement in a molecule of hydrogen sulfide. Show the outer shell electrons only. So hydrogen has 1 electron in its outer shell. Sulfur has 6 electrons. So draw 1 electron for each of the hydrogens, 6 electrons for sulfur, and then double check to make sure they're both full. Yeah, there's 8 electrons around sulfur and 2 for each of hydrogen, they're full. Balance the chemical equation for the reaction of hydrogen sulfide with sulfur dioxide shown. Let's start with the oxygen. We have 2 oxygens here, only 1 there, so I'm going to pop a big 2 there. That now brings us up to 4 hydrogens on the right-hand side. We've only got 2 there, so I'm going to put a 2 here, and then count the number of sulfurs. 2 sulfurs plus 1 there is 3. We've only got 1 on the right-hand side, so we need a 3. Ethanoic acid is manufactured by the reaction of methanol with carbon monoxide. An equilibrium mixture is produced. State 2 characteristics of an equilibrium. First of all, it's the rate of the forwards reaction equals the rate of the reverse reaction. I must write really big. And secondly, the concentrations of reactants and products are constant. The purpose of the industrial process is to produce a high yield of ethanoic acid at a high rate of reaction. The manufacture is carried out at a temperature of 300 degrees. The forward reaction is exothermic, so delta H is negative. Use this information to state why the manufacture is not carried out at temperatures below 300 degrees or above 300 degrees. So below 300 degrees would mean that the rate of reaction was too low, because collision theory would mean an infrequent number of successful collisions. And then why is it not carried out above 300 degrees? Because we've been told that that forward reaction is exothermic, meaning that if the temperature got too high, the yield of ethanoic acid would be too low. Complete the table using only the words increases, decreases, or no change. If you added a catalyst, what is the effect on the rate of the forward reaction? It would increase. What about if you decrease the pressure? Well, if you decrease the pressure, those particles are further apart, so the rate of reaction is slower. Decreases. The effect on the equilibrium yield. To decrease the pressure, we need to check the number of moles on each side. It's 2 moles on this side. 1 plus 1 is 2. 1 mole on this side. So if you were to decrease the pressure, you would move the position of equilibrium to the left, which would decrease the yield. Suggest which of the following metals is a suitable catalyst for the reaction. Give a reason for your answer. You want to pick a transition metal. Remember, they can act as catalysts. The answer here is cobalt. Just double check the position of that element in the periodic table and you'll see that it's a transition element. Ethanoic acid is a member of the homologous series of carboxylic acids. State the general formula of this homologous series. It's CnH2n plus 1 plus that functional group of the carboxylic acids, which is COOH. Draw the structure of the carboxylic acid with 3 carbon atoms, show all the atoms and all the bonds. So there's our 3 carbon atoms. There's the functional group. Get that in first of all, and then complete the molecule by adding hydrogens. Double check the number of bonds for each element. Remember, carbon forms 4 bonds, oxygen forms 2, and hydrogen forms 1. When carboxylic acids react with alcohols, esters are produced. The formula of an ester is shown. Name ester X. You might find this most straightforward if you actually draw it out. So that's the 2 ends of the ester. Remember, this end comes from the alcohol. There's only 1 carbon, so it's just methyl. And then the second part of the ester's name comes from the carboxylic end. There's 4, so it's butanoate. Methyl butanoate. Give the names of the carboxylic acid and the alcohol that react together to produce ester X. Well, I've already said the alcohol is this portion here, so it's methanol. And the carboxylic acid forms the butanoate, so it's butanoic acid. Ester Y has the following composition by mass. Calculate the empirical formula. So list your elements, draw a table, list mass, MR, number of moles. Here's your all-important formula triangle. In terms of the mass, remember you can use the percentages. The MR you'll need to find on the periodic table. To find the number of moles, we do mass divided by MR. And then finally divide by the smallest number. The smallest number here is 2.7. So you get 1.5, 3, and 1. You need a whole number ratio, so multiply everything by 2. Your final answer should be C3H6O2. Ester Z has the empirical formula C2H4O and the relative molecular mass of 88. Determine the molecular formula of ester Z. So what you have to do here is find the MR of the empirical formula they've given you. So that's 12 times 2 plus 4 plus 16. So that's 44. And then compare it to the molecular mass. The molecular mass is double, so we just need to double that empirical formula. C4H8O2. This question is about zinc and its compounds. Zinc is extracted from its ore, which is mainly zinc sulfide. The steps for this extraction are shown. Zinc sulfide is converted into zinc oxide. The zinc oxide is then reduced to zinc in a furnace. The zinc form becomes a gas. The gas is cooled to form molten zinc. Name the ore as zinc, which is mainly zinc sulfide. It is zinc blende. Describe how zinc sulfide is converted into zinc oxide in step 1. What you want to do is you want to heat that zinc sulfide strongly in air, so it will react with the oxygen present. Name the reducing agent used in step 2. We're taking that zinc oxide, we're removing the oxygen to form zinc. So what's causing the removal? It's the addition of carbon monoxide. Explain why the zinc forms as a gas in step 2 inside the furnace. What must we infer from that? It's that the temperature at which that zinc forms is higher than its boiling point. So temperature in furnace is higher than zinc's boiling point. State the name of the physical change occurring when zinc gas is converted into molten zinc. So we're going from gas to liquid, which means it's condensation. Zinc sulfate crystals are hydrated. Zinc sulfate crystals are made by reacting zinc carbonate with dilute sulfuric acid. Here's the equation. Large pieces of solid zinc carbonate are added to dilute sulphuric acid until the zinc carbonate is in excess. This forms aqueous zinc sulfate. The excess zinc carbonate is separated from the aqueous zinc sulfate. The aqueous zinc sulfate is heated until a saturated solution is formed. The saturated solution is allowed to cool and crystallize. The crystals are removed and dried. In step 1, zinc carbonate is in excess. When no more zinc carbonate dissolves, state one other observation that indicates the zinc carbonate is in excess in step 1. You would see no fizzing because you'd get no more carbon dioxide being produced. Name a different substance other than zinc carbonate that can be added to dilute sulphuric acid to produce that zinc sulfate. So how are we going to produce that salt, zinc sulfate, where you could use either zinc on its own, zinc oxide, or zinc hydroxide? Step 1 is repeated using powdered zinc carbonate instead of large pieces. All other conditions are kept the same. The rate of reaction increases. Give a reason why the rate of reaction increases. Explain your answer in terms of particles. So, powdered zinc has a higher surface area, meaning there are more frequent successful collisions. Per unit time. Suggest what is observed when the solution is saturated in step 3. You'd see crystals forming. The formula of zinc sulfate crystals is this. Give the formula of the solid formed if the crystals are heated to dryness in step 3. So you wouldn't have that combination with water, you just have the zinc sulfate. So that's ZnSO4. The periodic table is used to classify elements. Group 1 react with cold water to form alkaline solutions. Place the group 1 elements, cesium, lithium, potassium, rubidium and sodium in that order of reactivity. Put the most reactive element first. So have a look. Remember, as you descend group 1, the elements become more reactive. So the answer is cesium, rubidium, potassium, sodium, and finally lithium. Name the alkaline solution formed when cesium reacts with cold water. So you have cesium reacting with cold water to form cesium hydroxide plus hydrogen. So what is that called? It's cesium hydroxide. Group 1 elements have lower melting points than transition elements. Describe one other difference in the physical properties of Group 1 elements and transition elements. Remember, Group 1 metals are soft. Group 7 elements are known as the halogens. Astatine is below iodine. Predict the physical state of astatine at room temperature. So as you descend group 7, the melting point increases. So if iodine is a solid, it means that astatine is a solid. Some group 7 elements react with aqueous solutions containing halide ions. When aqueous chlorine is added to aqueous potassium bromide, a reaction occurs. The ionic half equations for the reaction are shown. Describe the colour change of the solution. So you go from having effectively potassium bromide to producing bromine. So you'd expect that potassium bromide to start off as being colourless, and then the final mixture will be brown. Identify the species that is oxidized and explain your decision. So oil rig states that oxidation is loss of electrons. Over here we have electrons being lost, and so the species being oxidized is the bromide, Br-. Bromine monochloride is made by the reaction between bromine and chlorine. The chemical equation is shown. Calculate the overall energy change for the reaction using bond energies. Use the following steps. Calculate the total amount of energy required to break bonds in 1 mole of bromine and 1 mole of chlorine. So you have one Br-Br bond and one Cl-Cl bond. Calculate the total amount of energy released when 2 moles of BrCl are formed. So we have 2 lots of BrCl, so 2 times 218. Calculate the overall energy change, so you do bonds broken minus bonds made to get minus 4 kJ.